Hello, I welcome you all for this session on the refrigeration and air conditioning. In the today's lecture, we are going to focus on to the two different particular parameters which are related to the unit number 5 for the refrigeration air conditioning, and some of the portion of this particular presentation is a part of the unit number 4 for the HVAC students. The two different topics that I am going to cover in the today's lecture are nothing but the one is the comfort conditions and second is nothing but the cooling load calculations. Both are nothing but the very important topics as far as the theoretical part is concerned for the comfort conditions, and the cooling load calculation for the basis of the foundation for the design of any air conditioning or the refrigeration system. So we'll discuss both the points one by one. So let us start with the comfort conditions. Now, whenever we are discussing the term comfort, so most of that point is basically related to the comfort of the human beings, isn't it? So our discussion would be essentially restricted for the human comfort. And very randomly speaking, the human comfort depends upon physiological and the psychological conditions. How physically you are being fit. A person who is considered to be physically fit can also be normally considered to be a comfortable one. And another parameter which also govern the comfort of the human being in nothing but is psychological condition, how psychologically he is fit. So both the parameters are very important to take into consideration the comfort of the human beings. But as we can also predict that the human comfort is nothing but a very big term or very large term, and one cannot specify the comfort just restricting to these two words. So hence it would be very much difficult for us to define the term human comfort, because the human comfort would be basically affected by the various conditions like that of various parameters, just like that of the habit of the eating, then the age of that particular person, and the type of the clothing those are being normally practiced by that particular person, the gender of that person, or the kind of activity or the work that has been say particularly done by that person. So these are nothing but some of the parameters that may affect the human comfort as well, or these parameters should be taken into consideration while giving the human comfort. So it is a very general term that we can say. But the most accepted definition from as far as the subject point is concerned, that has been given or stated by the American Society of Heating, Refrigeration and Air Conditioning Engineers, that is nothing but the ASHRAE. And what ASHRAE states, the definition for the human comfort is that the human comfort is that condition of the mind which expresses the satisfaction with the thermal environment. It is very important term which should be taken into consideration here, nothing but the thermal environment. So your mind, your body, that will express the satisfaction, that will express an equilibrium with the surrounding environment or the thermal environment. So first we should take into consideration that what are the factors that should be taken into consideration for the requirements of the human comfort. So some of the parameters are mentioned in this particular slides. Now the parameters that affect the human comfort may not be necessarily restricted only to this 5 or 6 point mentioned here. These are just the tentative points which are mentioned. So other points may also be taken into consideration to give the requirements of the human comfort. One of the very important one is nothing but the supply of the oxygen and the removal of the carbon dioxide from the confined space or the conditioned space. Because oxygen that is required for the metabolism, that is nothing but for the conversion of the energy of the food that you are say consuming. So that food is converted into some thermal energy which can be further converted into mechanical energy, and the remaining energy that may be say rejected to the surrounding as well. So oxygen is required for the combustion of that food and resulting in the releasing of the carbon dioxide. So it is essential that the appropriate level of the oxygen should be maintained in the environment that is to be conditioned, and there should be the simultaneous removal of the carbon dioxide as well. So increasing the carbon dioxide level, that indicates rather there is a not sufficient supply of the oxygen. So both should be taken into consideration simultaneously. Sufficient supply of the oxygen and the simultaneous removal of the carbon dioxide from the environment. The removal of the body heat dissipated by the occupants. Occupants is nothing but a human being. And all of us know that the human being is nothing but considered to be a thermal engine, isn't it? Which converts the energy which convert the food into the thermal energy with the help of the metabolism. We get the energy for carrying out our day-to-day activities. So the remaining portion of the energy which is not converted into the useful work is then dissipated to the surrounding by the occupants. So it is essential that the surrounding environment, surrounding atmosphere must be capable of absorbing the heat which has been say, dissipated by the human body to the surrounding. So along with the heat which has been say, dissipated by the human body or by the occupants, the moisture is also dissipated by the occupants to the surrounding. And roughly we can say that around 50 grams of the moisture is continuously dissipated by the human body to the surrounding, even if that person or the human is not carrying out any uh, major physical exercise, even if he is in say at the very comfortably sitting at one place without doing much of the any physical activity. So the amount of the moisture that is dissipated by the human body may be up to 50 grams per hour. So surrounding atmosphere must be capable enough to absorb the moisture which has been say dissipated by the human body, which will definitely affect the comfort of the human being. It is also essential that the air which is say conditioned with the appropriate level of the oxygen, carbon dioxide, absorbing the heat, and the body moisture as well. So sufficient air movement must also be maintained, or there should be the proper distribution of the air in the space which has to be conditioned. Then and then only the effect of that conditioned air can be felt by most of the occupants which are sitting in that air conditioned space, air conditioned region. So it is essential to provide the sufficient movement of the air, and the air should be evenly distributed rather in the occupied space. Along with that one, the purity of the air should also be maintained, because the air may contain some bad odor or the smell, especially the smoke, then the dust, the bacteria, and the viruses, the undesirable ingredients. So all those must also be removed before the air is admitted to the conditioned space. So we can say that all these are very important or the vital parameters as far as the comfort of the human being is taken into consideration. It is necessary for us to understand that what is the thermal exchange of the body with the environment. That means that how the thermodynamics of the body actually is taking place. So this thermodynamics is basically whatever the discussion that we had on this particular slide. So that is essentially related to the balance of the energy. Isn't it? The energy which is dissipated by the human body and the energy which is absorbed by the surrounding atmosphere. So this balance of the energy or the exchange of this energy of the human body with the thermal environment. The human body that maintains its thermal equilibrium with the environment by three different modes of the heat transfer: radiation, convection, and the evaporation. I will intentionally not say here the conduction mode of the heat transfer. I will specifically use here the word evaporation, because evaporation is also nothing but one mode of the heat transfer with the phase change. Even though the temperature remains constant during the evaporation, but the heat transfer takes place. That is, the latent heat transfer rather takes place. So we can say that this evaporation is nothing but the heat transfer accompanied with the phase change. So this thermal equilibrium depends upon these three modes of the heat transfer: the radiation mode of the heat transfer, the convection mode of the heat transfer, and third one is nothing but evaporation. And the human body normally feels comfortable when the heat produced or the heat generated by the metabolism of the human body It means that the heat has been generated by the digestion of the food. So definitely some energy is required for the conversion of this food into the useful energy, isn't it? And the heat is produced during this metabolism. So whatever the heat which is generated, which is produced by the human body due to this metabolism, must be equal to the sum of the heat dissipated to the surroundings. The heat generated by the human body must be equal to the heat which is dissipated to the surrounding body, and the heat which is stored in the human body by rising the temperature of the body tissue. Isn't it? So how these parameters can be represented mathematically? The different heat exchanges which are taking place with the surrounding by the human body. So that can be given in terms of a mathematical equation. So that mathematical equation can be given as Qm minus W equal to QE plus minus QR plus minus QC plus minus QS. So let us see what are these different terms, what are the meaning of these different terms. Qm, the metabolic heat produced within the body, the energy that is produced by the body due to the digestion of the food. W is nothing but the useful rate of the working, because we know that the human body is nothing but a thermal engine. It will consume the energy available from the food and it will convert that into some useful work. So that is nothing but the useful rate of the work. Normally, it is considered that the thermal efficiency of the human body is nothing but only 20%, isn't it? So, useful rate of the working is nothing but only the 20% of what the heat which has been generated by the human body, and whereas the rest of the 80% of the energy generated by the human body is rejected to the surrounding, it is dissipated to the surrounding, isn't it? So, that 80% of the heat energy released to the surrounding, dissipated to the surrounding, is nothing but by these three modes of the heat transfer. And this algebraic sum, that is Qm minus W, Qm minus W is nothing but the heat to be dissipated to the atmosphere. So heat generated and useful rate of the working. So remaining is nothing but the heat which has to be dissipated to the atmosphere. So 80% of the heat we can say generated by the human body will be dissipated to the surrounding. So these parameters would be there on the left hand side, this Qm minus W, and this energy should be balanced with the other parameters, other factors which are mentioned on the right hand side. So what are those? QE, the heat lost by the evaporation, means whatever the sweating that we can have on our skin due to some physical activity, so that will be dissipated to the surrounding by the evaporation. Surrounding air will come in contact with the skin surface and will take out that moisture, will take out the sweating which is present on your skin. So there will be the change of phase. So it is nothing but the latent heat which is transferred to the surrounding. So that's why it is nothing but the heat lost by the evaporation. In the QR, heat which is lost or the gain by the radiation, isn't it? QC, heat which is lost or gained by the convection mode of the heat transfer, and QS is the thing but the heat which is stored in the body. So due to this heat which is stored in the body, the human body temperature that remains nearly constant, equal to say 37 degrees Celsius, 36.5 to 37 degrees Celsius, or maybe up to 97.5 to 98 degrees Fahrenheit. It would be also seen that on the right hand side, this particular plus minus, plus minus, plus minus, positive, negative signs are being assigned to this QR, QC, and QS. Whereas for the QE, that is nothing but always positive. It means that the heat which is lost by the human body to the surrounding by the evaporation is always positive. Okay, so it means that the heat loss is taken to be the positive. So this QR and this QC will be taken positive when the heat is lost by the human body to the surrounding. The human body temperature being higher than the surrounding temperature, then heat would be lost to the surrounding, it would be considered to be the positive. And if the heat is gained by the human body from the surrounding environment, from the surrounding atmosphere, then the negative sign would be there for the QR and the QC. And for the QS, if the QS is to be the positive, heat which is stored in the human body is positive, it means that there is a rise in the temperature of the human body. And similarly, vice versa, negative, that is nothing but heat which is lost by the human body to the surrounding. Isn't it? So heat stored will get reduced, and that will cause the drop in the temperature of the human body. So it is essential that both of these sides must be say maintained, or they should be properly balanced. And if there is a imbalance between the parameters or the factors on the left hand side and the right hand side, so these factors may lead to the uncomfortable conditions for the human body, which are not the desirable. So it is essential that both should be balanced at any circumstances. If this is not balanced, the terms on the left hand side and the right hand side are not balanced. There is an imbalance of the energy, and suppose the heat is stored in the human body, which causes a rise in the temperature of the human body. Then let us see what are the undesirable effects of this one. So these are nothing but some of the physiological hazards resulting from the heat. And we normally see such types of the hazards resulting there in the summer season. Now, currently we are going with the summer season. So these are some of the uh, hazards which may affect on the human body. What are those? The first one is nothing but heat exhaustion. Now, due to the higher surrounding temperature, so the blood circulation which normally takes place in the human body, that is getting adversely affected. The pressure of the blood which is there in our body, that gets disturbed, we can say that, or the blood vessels get slightly expanded, and then there will be the pooling of the blood in the lower limbs of the human body. So it causes, and less amount of the blood will be circulated toward the heart and toward the brain as well, isn't it? So due to the failure of the normal blood circulation, so the heat exhaustion normally takes place due to the failure of the blood circulation. And some of the symptoms which are nothing but the indicators for the heat exhaustion are nothing but the fatigue. Okay, you may feel fatigue, you may feel the tired after carrying out a little bit amount of the work. Then severe headache may be there, the dizziness is there, and in some of the cases, the vomiting may also take place due to the abnormal, what you can say, the drop in the blood pressure, and the abnormal mental reaction as well, such as the irritation or the angry nature that one can also say realize due to the heat exhaustion. Heat exhaustion may cause the fainting, meaning that the face may become a pain, your skin may become a pain due to the heat exhaustion. And even though this particular heat exhaustion does not cause the permanent injury to the body, and the recovery is usually a rapid one, when the person is removed to a colder place, you can take that person away from the direct sunlight and immediately move that person to a somewhat colder place, so that the recovery may be rapid to overcome the hazard of the heat exhaustion. The heat cramp. The heat cramp is the one which normally results due to the loss of the salt due to the excessive rate of the body perspiration. It means that the body will lose most of the water as it is appearing in the form of the sweat, and along with the sweating there is also loss of the salt as well. Normally the people who are say working in the what do they say, intense high temperature atmosphere, isn't it? Or the laborers which are working in the say particularly municipal work, there is a digging work which has been say normally taking place. So these people normally result from such hazard, that is heat cramp, and excessive loss of salt and excessive loss of the water normally takes place. And the symptoms may be the severe pain in the calf and the thigh muscles, or your muscle joints may be a severe pain, and it can be largely avoided by using the salt tablets or by consuming the water at the regular intervals. Yeah. Third one is nothing but the heat stroke. Now, this, as far as the above two things are being concerned, two hazards are concerned, that is the heat exhaustion and the heat cramp. The heat stroke is considered the most hazardous one or the deadly one. When exposed to the excessive heat and the work, the body temperature may rise rapidly to the 40.5 degrees Celsius or maybe even higher. The severe kind of a physical activity which is done by a person which is say exposed to uh, excessive heat, or say in the high atmospheric temperature region. So the temperature may shoot up to 40.5 degrees Celsius or maybe up to 105 degrees Fahrenheit. That may be a fatal one. At such temperature, the sweating ceases and the man enters into the sweating ceases, the skin becomes dry and man becomes or that particular human may enter into the coma, which is the last stage before your death. And if the appropriate measures are not taken, then the death is a certain one, the imminent one. The heat stroke may have a permanent damage to the brain as well. The brain damage may be permanent due to the heat stroke. So it can be avoided by taking the sufficient water at the frequent or the regular intervals. So do consume the water at the regular intervals and sufficient quantities as well. Isn't it? So if you want to get away from this all the hazards, so you should take the proper care in the summer season. The factors which are affecting the comfort of the human beings, so some of the factors that we have seen that what are the requirements of the human comfort rather, and the factors which affect the human comfort can roughly be given as effective temperature. I will specifically say this is an important term, that is nothing but the effective temperature. We are going to define this effective temperature and what is the importance or the relevance of this effective temperature in the subject of the psychrometry. Heat production and the regulation in the human body, the heat and the moisture losses of the human body, that just we have discussed in the earlier slides as well, during the thermodynamic equilibrium, or say the during the thermal interaction of the human body to the surrounding, moisture content of the air, quality and quantity of the air, and the air motion, hot and cold surfaces, and the air stratification. So these are very important factors that affect the comfort of the human body. I will discuss the important one, nothing but the effective temperature. So let us see what the effective temperature is given at. The degree of warmth, that is nothing but the warmness. The degree of the warmth or the cold which is felt by the human body, that depends upon the following factors, three factors. Or it is nothing but the degree of the comfort, we can say. The degree of the comfort felt by the human body, that depends upon the tribal temperature, that is the DVT, relative humidity, that is the phi, and the air velocity. And the combined effect of these three factors is taken into account by introducing the term that is known as the effective temperature. The effective temperature is the one which takes into account all these three parameters simultaneously: the tribal temperature, the relative humidity, and the air velocity. So it is normally defined as the index, or nothing but an indicator, okay, the numerical value or the indicator which correlate the combined effects of the air temperature, relative humidity, and air velocity on the human body. So what the effective temperature is given as? The numerical value of effective temperature is made equal to, okay, very important one. The numerical value of the effective temperature is made equal to the temperature of the still saturated air. Still saturated air, it means that a fully saturated air, 100% saturated air, which is still, it means that the air velocity is somewhere between the range of 5 to 8 meters per minute. So is made equal to the temperature of the still saturated air, which produces the same sensation of warmth or comfort, which produces the same sensation of the warmth and the coolness as produced under the given conditions. So it means that the comfort which has been say given by the air which is fully saturated at a particular temperature, and the comfort which is given by the air at the same temperature which is unsaturated one, isn't it? So the numerical value of that temperature will be given as an effective temperature. Okay, and this application of the effective temperature is there for the production or the representation of a comfort chart. This comfort chart is nothing but a graphical representation of the various parameters of the various factors. This is one of the comfort chart. But let me discuss another comfort chart which will be there in the next slide as well, because as such the units which are mentioned here for the various parameters, so those are say expressed in PSI units. Those are expressed in PSI unit. So we are very much conversant with the SI units. So this is nothing but the comfort chart where the values of almost all the parameters or the factors are expressed there in the SI units. So let us see what are the silent features of this comfort charts are. So the comfort chart is nothing but the graphical representation of wet bulb temperature there onto the y-axis against the dry bulb temperature there onto the x-axis. Okay. So the comfort chart for a still air with a velocity that is somewhere between 5 to 8 meter per minute. We are in the dry bulb temperatures on x-axis ranging from 10 degrees Celsius to around 38 degrees Celsius, and similarly the wet bulb temperature that would be say around some 0 2 degrees Celsius, okay, 2, 4, 6, and 10. So from 2 degrees Celsius say around to 32 degrees Celsius, maximum value 32 degrees Celsius. And it would be seen that this comfort chart is divided into the three different regions. The one region which is there onto the say upper left corner. So this region, the thing with the upper left corner, which is mentioned there, applicable for the summer season, isn't it? It is applicable there for the summer season, the upper left corner. Then the region which is there on the lower right corner, okay, this particular region, lower right corner, which is applicable there for the winter season. And then say intermediate region. It's an intermediate region between which a hatched portion or the section portion has been shown here, which is nothing but called as the comfort zone. So this comfort chart is the one which actually indicates that how much percentage of the people will feel comfortable at a particular values of the dry bulb temperature, wet bulb temperature, relative humidity, and which are taken into account by introducing a single term that is known as effective temperature. So let us see. Now, along with the dry bulb temperature and wet bulb temperature lines, the other lines which can be seen here, okay, this particular line, I will see that. Okay, it is mentioned on the right hand side, it is nothing but the 10%. Above that one, 20%, 30%, 40, 50, 60, 70, 80, 90, 100. So all these lines are nothing but the relative humidity lines. Okay. All these lines, inclined lines, are nothing but the constant relative humidity lines. A constant relative humidity line of 20%, constant relative humidity line of somewhere here it is nothing but the 70%, and likewise. And the other temperature lines can also be seen here. Okay, this one here it is mentioned 12. A constant value of 12 which is mentioned, a constant value of 13 would be there, a constant line of having the value equal to 14, 16, and maybe up to 28, 30, 31 degrees Celsius. So all these lines are nothing but the constant effective temperature lines. So this is the line of constant effective temperature 10 degrees Celsius. This is there for the 12 degrees Celsius, constant effective temperature at 13 degrees Celsius, 14 degrees Celsius, and likewise. Okay. So four temperature lines, four constant lines that we have seen here. The constant wet bulb temperature lines, constant dry bulb temperature lines, vertical. Inclined lines are nothing but the constant relative humidity lines, and the oblique lines are nothing but the constant effective temperature lines. Now coming on to the upper left corner of this comfort chart, which is applicable there for the summer season. It will be seen that on this y-axis of this rectangle, it is seen that percentage of the people feeling comfortable. Okay, percentage of the people feeling comfortable. So it is 0%, 10%, 20, 30, 40, 50, 60, 100% of the people feeling comfortable. So similarly, there is one curve as well. Only a small portion of that curve has been shown here for the winter season, but same can be extrapolated till it reaches the bottom of this particular rectangle, we'll say somewhere here. Isn't it? If this curve has been say extrapolated, it would cut somewhere here. And if it is extrapolated on the other side, it is going to cut somewhere here as well. And this along this curve, along this, you can say the inverted U-shaped curve, and this one would be say the U-shaped curve. It will be seen that if we see the peak of this particular curve, where the value would be nearly equal to say around 97-98%. Isn't it? It means that at this particular value, 98% of the occupants which are sitting in that air conditioned space in the summer season will feel comfortable, provided the temperature is somewhere near around 21.5 degrees Celsius, somewhere here. Okay, somewhere here I can have. around 21.5 or 21.6 degrees Celsius. So almost 98% of the occupants will feel comfortable when the effective temperature is of the order of 21 degrees Celsius. Okay, so this is also a line of constant effective temperature of 21 degrees Celsius. But it will be seen that somewhere around 90% of the people will feel comfortable when it is a winter season. So it means that even though the effective temperature being the same, even though it is a summer season or the winter season, but the percentage of the people that may feel comfort at the same effective temperature would be different. If I see at this particular value, isn't it, effective temperature, how much it is here, it is 18 degrees Celsius, a constant effective temperature line of 18 degrees Celsius, a constant effective temperature line of 18 degrees Celsius, and the relative humidity being 100%. So it is 0% of the people that may feel comfortable there in the summer season, isn't it? But if I move along the same line at 18 degrees Celsius, okay, where in the summer season 0% of the people were feeling comfortable. If I move along this one, around 18 degrees Celsius. If I go somewhere here, so it will be somewhere around 80% of the people may feel comfortable. 80% of the people may feel comfortable. And around that 18 degrees Celsius effective temperature line as well, there is a range for the specific humidity, relative humidity. There is a range of the relative humidity as well. So relative humidity that varies in the range of 30% to the maximum of around 70%. So it would be seen that for this comfort zone, the temperature limits are mentioned as I say 18 degrees Celsius effective temperature, and here it is a 21 degrees Celsius. So effective temperature ranges between 18 degrees Celsius to 21 degrees Celsius, and the relative humidity that varies between 30% to the 70%. So within this particular temperature and relative humidity range, most of the people may feel comfortable whether the season is considered to be the summer season or whether it is to be considered as a winter season. Okay, so that is nothing but the applicability or the usability of the comfort chart. Comfort chart lets us to know how much percentage of the people are feeling comfortable at a particular value of the effective temperature and relative humidity in both the season, summer season as well as in the winter season. So all those things, whatever that we have discussed till now, were applicable for the comfort of the human beings. So we have seen what are the requirements of the human comfort, what is the thermodynamics of the human comfort, then what are the factors which are affecting the human comfort, the definition of the effective temperature, and the application of this effective temperature for the comfort chart. Isn't it? So all this discussion is basically related to the comfort of the human beings. That was nothing but the first part of the today's discussion. And in the coming discussion, which may be around say 10 to 15 minutes, we will be discussing about the cooling load estimation. Cooling load estimation is nothing but one of the important steps in the designing of the air conditioning equipment or the refrigeration equipment. The design engineer or the HVAC engineer should be very well conversant with the various parameters before he is designing an equipment which is going to produce the required refrigeration effect or the cooling effect, isn't it? Because both of these devices, the air conditioner as well as the refrigerators, they are supposed to say take the different kinds of the loads and produce the cooling effect or the refrigeration effect. So one must be aware with what are the different sources that one can take into account before designing an air conditioning or the refrigeration equipment. So what is this one? The total heat required to be removed from the space. It means that this is nothing but the refrigeration effect or the cooling effect that should be taken into account, that should be produced by the equipment. So the total heat required to be removed from the space in order to bring it at the desired temperature. It means that the required temperature by the air conditioning and refrigeration equipment is known as the cooling load. So the cooling load in brief is nothing but the amount of the heat that must be extracted, amount of the heat that must be taken out from the space that has to be refrigerated or that has to be air conditioned as per our requirement. Before we start the system, the system would be at the ambient temperature, and we should continuously take out the heat from that space which has to be conditioned so that the required temperature can be obtained. It means that we need to continuously pump the heat from the space to be conditioned, and this pump heat has to be thrown somewhere outside that conditioned region. So that is what we are saying here, the total heat which is required to be removed from the space. So which is nothing but the load which should be handled by the refrigeration or the air conditioning equipment, load on the system. So what is the purpose of this load estimation? What is the purpose of this cooling load estimation? The purpose of this load estimation is nothing but to determine the size of the air conditioning and the refrigeration equipment. Size of the equipment, it means that I should take into consideration the design of an compressor. The compressor shouldn't be too bulky, or it shouldn't be but too small, too tiny, so that it won't be say working according to the requirements. And the sizing of the condenser, then the sizing of an say the evaporator, then one can say the sizing of an control equipment, that is nothing but expansion devices like that of an capillary tube, thermostatic expansion board. So all the sizing of this equipment would be essentially dependent upon the how effectively or how accurately you can calculate the cooling load. So it forms the foundation for the design of an air conditioning equipment. So the purpose of the load estimation is to determine the size of an air conditioning or the refrigeration equipment that is required to maintain inside design conditions during the periods of the maximum outside temperature. Because if we see for the comfort of the human being, so more or less the requirements of the temperature or the inside conditions will be more or less same whether the summer season is there or the winter season is there. But the outside conditions may not necessarily remain the same, isn't it? During the summer, outside temperatures are quite high, the conditions are quite hot, and vice versa are the conditions there into the winter season. But the inside conditions that are going to remain more or less the similar one, unchanged one. So this design load or the cooling load is based on the inside and outside design conditions, and it is the air conditioning and refrigeration equipment capacity to produce and maintain a satisfactory inside condition. Refrigeration air conditioning equipment capacity, it means that the ton of refrigeration. So what should be the ton of refrigeration? That is the capacity of the refrigeration air conditioning equipment. The equipment shouldn't be designed for the too large of a TR or the too small of a TR. Okay, ton of refrigeration capacity. It should be appropriately designed for that particular load which would be handled by that equipment. So what are the different components of this cooling load? Is it the load which has to be removed, or the heat which has to be removed from that refrigeration air conditioning equipment? So there are, broadly speaking, the two components of the cooling load are there. One component is called as the sensible heat gain. That is nothing but there would be existing some sources in the space to be conditioned which will make the contribution for the sensible heat. And another is nothing but the latent heat gain. Similarly, there would be some sources which will make a contribution for the latent heat. So your equipment, refrigeration or the air conditioning equipment should be capable of taking the addition of both the loads, the sensible load and the latent load. Isn't it? So in the earlier part of the discussion, when making the solving the numericals onto the psychrometric processes, psychrometric properties, we came across one term that is known as sensible heat factor. Isn't it? So sensible heat factor, that is the ratio of the sensible heat divided by sensible heat plus the total heat. So this total heat is nothing but the summation of the sensible and the latent heat. Isn't it? So this sensible heat gain is essentially due to the direct addition of the heat into the enclosed space. This enclosed space is nothing but the air conditioned space, the space that should be maintained according to our requirements. So the direct addition of the heat into the enclosed space is the one that makes the contribution for the sensible heat, and this heat has to be removed. It has to be pumped normally during the process of the summer air conditioning. Okay, that is the thing of the cooling and dehumidification. Isn't it? Similarly, onto the latent heat gain side, there is addition of the water vapor, the humidification that is taking place. Addition of the water vapor is taking place into the space that has to be conditioned. So there is the addition of the water vapor to the air of an enclosed space or the air conditioned space. The direct addition of the heat that results in the increase in the temperature. Then the addition of the water vapor that results in the humidification of the enclosed space. Isn't it? So that's why the heat has to be removed during the process of the summer air conditioning. And the primary requirement for the summer air conditioning is nothing but the simultaneous cooling and dehumidification. The drop in the temperature, decrease in the temperature, along with the decrease in the specific humidity. We have seen some of the numericals in the earlier sessions there for the cooling and dehumidification. So during that cooling and dehumidification process, both the loads will be taken into account simultaneously: sensible heat load and the latent heat load. Now, what are the different sources which are, say, making the contribution for the sensible heat and the latent heat gains? Because whenever the numerical or the problem that will be, say, given to you to design of an air conditioning system for some specific application, maybe for the small library application, maybe for a small restaurant, then you should be in a position to identify what are the sources which are, say, making the contribution for the sensible, and what are the sources which are making the contribution for the latent heat. So both the sources should be differentiated properly, and we will add all the sensible loads together and the latent load together to get the total heat load. So let us see what are the sources one by one which make the contribution for the sensible heat gain. You know that the sensible heat gains are the one which are, say, resulting due to the direct heat addition. So these sources will essentially result in the increase in temperature rather than increase in the moisture. Okay. So heat flowing into the building by the conduction through the exterior walls, floors, ceilings, doors, and windows due to the temperature difference on their two sides. So what we are having? We are having the walls, then the roof, the ceiling, the doors, and the windows. Isn't it? So definitely there is some temperature gradient or there is the temperature difference which is existing across the walls, across the floor, across the ceiling. Normally in the summer season the surrounding temperature is high. Inside temperature that is required to be maintained will be low. So due to this temperature difference, positive temperature gradient, so heat will be continuously flowing from the surrounding into the space that has to be conditioned. Heat will be conducted rather. Heat transfer will take place by the conduction through the finite thickness of the wall, finite thickness of the floor, finite thickness of the ceiling, doors, and windows. Because all these particular components, walls, floors, ceilings, doors, windows, so these will be made up of a material having a lower thermal conductivity. Even though they are being the poor thermal conductors due to their less thermal conductivity, but still some amount of the heat would be, say, dissipated from the surrounding into the space that is to be conditioned. Isn't it? So it will be essentially transferred by the conduction to the temperature gradient delta T across the wall. So direct heat addition. The another parameter is nothing but the heat which is received from the solar radiation. And normally the heat which is received from the solar radiation that normally varies throughout the day, isn't it? The heat received from the solar radiation that doesn't remain constant throughout the day, isn't it? So the heat which is transmitted directly through the glass of the window, ventilators, and the doors. If you are having the windows which are, say, made up of the glass, some ventilators, and the doors made of the glass, so definitely the solar radiations will be directly impinging onto this glass and will be directly admitted into the space that is to be conditioned. Then the heat absorbed by the walls, roofs, which are exposed to the solar radiation, and later on transferred to the room by the conduction. So heat would be absorbed by these walls in the ceilings or the roofs due to the solar radiation which are falling on that way, and it will be, say, conducted. It will be conducted through the finite thickness of the wall, and that will be admitted there into the room that has to be conditioned. Another major important parameter which makes the contribution for the sensible heat gain is nothing but heat conducted through the interior partitions of the rooms in the same building which are not conditioned. It means that suppose in a particular building uh, there are the two flats, your own flat and there is another flat which is adjacent to you, and you might be say having a one common wall, okay, one common wall which would be shared by both the flat owners. The flat owner which is there adjacent to you, which is your neighbor, so that particular room is conditioned by there was some air conditioner, so his room would be say maintained at the required temperature. But the wall which is say common with your flat, and suppose your room is not conditioned, so which will be at a higher temperature. It means that across the common wall, there would be the temperature gradient, isn't it? The face of the wall which is there on your room side, so that will be at a higher temperature as it is unconditioned, and the face of the wall which is there on your neighbor side, which is say conditioned, so that will be at the lower temperature. So heat will be transferred from the surface of the wall of your room to the surface of the wall of the person which is say your neighbor. It means that the heat would be transferred from your room to the person who is say residing to your neighbor, isn't it? So it means that the neighbor is also indirectly cooling your room as well, isn't it? So heat is conducted through the interior partition of the rooms in the same building which are not conditioned. Heat which is given up by the lights, motors, machinery, cooking operation, industrial processes, etc. So various electrical and electronic equipments would be used in that particular space which is air conditioned. You might be having the computer in your room. You might be having say the server in your room. You might be say, having the different lights and different electrical equipments in your room. So they will continuously dissipate the heat to the surrounding as well. Due to some cooking operation, hot utensils are being say brought. Uh, 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 some of the food items are served to you in the hot utensils. Whenever you are say visiting any air conditioned restaurant, hot chapati is served to you, hot soup is served to you, hot cup of coffee is served to you. So definitely the heat is also being added due to these sources, the different industrial processes. So there will be such sources which make the contribution for the sensible heat gain. Heat liberated or dissipated by the occupants to the people which are say, sitting in the air conditioned space. We have just earlier said that the human body is nothing but a thermal engine which dissipates the heat continuously to the surrounding, isn't it? So heat will be continuously liberated, dissipated by the human body, the surrounding as well, which will increase the temperature of the surrounding. The heat which is carried by the outside air which leaks in, also called the infiltrating air through the minor cracks in the doors, windows, and through their frequent openings. Okay, some amount of the air, outside air, would be directly admitted into the air conditioned room, air conditioned space, due to the frequent opening of the door. Isn't it? People may be entering into the room, they might be say leaving the room as per their requirement, as per their convenience. There would be certain cracks or the certain gaps in the windows, in the doors, or in the wall as well. So through which the air might be continuously leaking into the space that has to be conditioned. Okay, so this infiltrated air also forms the contribution for the sensible heat gain, sensible heat load. Then the below two mentioned sources are nothing but miscellaneous sources, I will say. The heat gain through the walls of the ducts carrying the conditioned air through the unconditioned space in the building. It means that suppose you are there in a say commercial building, say in a bank or say in an office, a large bank, large office, uh, in a say the theater or a mall, then you cannot have a number of window air conditioner which are installed there, isn't it? So you would be having a centralized air conditioning system where the air would be conditioned at one particular place, at certain location, and that conditioned air would be passed through the ducts, okay, which are nothing but the rectangular pipes or say the circular pipes. So these are nothing but the ducts. So this conditioned air will be passed through the ducts and it will be admitted. It will be say say, injected into the space that has to be conditioned. So this is very normal experience that if we visit any auditorium, any theater, or for that matter, any shopping mall, isn't it? So air would be admitted through the ducts in such a commercial establishment. And while carrying this air through the ducts, so the ducts would be say passing through the region which is unconditioned. So the temperature of the air passing through the duct is lower, and temperature of the air which is surrounding the duct is the higher one. So ducts would be made up of certain material, even though the insulation is added over the duct material to isolate it from the surrounding. Still, that insulation would have some finite thermal conductivity, and heat would be say continuously transferred from due to this temperature difference by the conduction from the surrounding air to the air which is say passing through the duct. Then the heat gain from the fan work. Heat gain from the fan work in that the fan would be essentially used in the will be used for the proper distribution of the air into the space that has to be conditioned, isn't it? So you need to appropriately distribute, and you need to cause the appropriate air movement so that the effect of the air can be felt throughout the space that has to be air conditioned. So some of the work would be required for the fan, so the electrical energy will be required for the operation of the fan to maintain the positive flow of the air, and due to the work of the fan, some energy, some heat would be differently added into the space that has to be conditioned. So all these are nothing but the sources which make the contribution for the sensible heat gain. I would like to insist once again that if a lengthy problem has been say given to you with the different heat sources, 5 10 different heat sources are mentioned to you, your concept must be clear enough that you can appropriately classify that these are the sources which make the contribution for the sensible heat. These are the sources which make the contribution for the latent heat. So all these were the sources for the sensible heat. So let us see what are the sources for the latent heat gain. Remember that the latent heat gain is nothing but the heat which has been say admitted due to the moisture, okay, which will result in the humidification of the air conditioned space. So what are these? The heat gain due to the moisture in the outside air entering by the infiltration. So just now we have seen that infiltration, isn't it? So air that is admitted to the frequent opening of the doors, opening of the windows, then minor cracks which would be there from the door or the walls. So some of the air would be continuously leaking into the space. So the surrounding air which is having the high humidity then, isn't it? So that moisture would also be carried along with that air which is entering into the space that has to be conditioned. Heat gain due to the condensation of the moisture from the occupants. So we know that not only the human body that dissipate the heat to the surrounding, but whatever the sweating that we are having on our skin, so that sweating is nothing but the moisture which is added into the surrounding room. So this moisture is continuously dissipated by the human body to the surrounding air or the conditioned space. We have seen that earlier that approximately 50 grams of the water vapors are being added, or the water is being added by the human body to the surrounding. So one can imagine that say that theater of around 500 capacity, how much of the moisture would be say, dissipated by the occupant to the surrounding? A very big moisture would be dissipated by the surrounding to the surrounding by the occupants. Heat gain due to the condensation of the moisture from any processes such as the cooking foods which takes place within the conditioned space, isn't it? You are being served a cup of a coffee or the cup of a tea, isn't it? So it would be say releasing the vapors would be continuously coming out of from that way. So these water vapors are continuously added. This water vapor is nothing but the moisture which is getting continuously added into the surrounding space. The hot soup that is say served to you, so the vapors will be coming out of that from soup, which will be added as a vapor into the surrounding air, isn't it? So as these vapors will be coming in contact with the cold surface, so this condensation of the moisture is likely to take place. Then heat gain due to the moisture passing directly into the conditioned space through the permeable walls and partitions from the outside air or from adjoining regions where the water vapor pressure is higher, isn't it? So due to the vapor pressure difference, okay, across the walls inside the room and outside the room, so due to this vapor pressure difference, some amount of the water vapor or the moisture would also be admitted directly into the space, okay, across the walls or the partition. So that's all for the this particular lecture for the refrigeration air conditioning. And the two important points that we have discussed for this particular session. Uh, uh, the first point that we came across was nothing but the comfort of the human being or the comfort conditions, and the second is nothing but the cooling load calculation. What are the different sources that should be taken into consideration uh, before, say, making the uh, before designing any air conditioning or the refrigeration equipments? We should classify the sensible and the latent heat sources. So I hope that you have understood these two factors properly, and definitely some theoretical questions would be there in the examination regarding both the topics that we discussed: the comfort of the human beings, parameters affecting the comfort of the human beings, effective temperature, comfort chart, and the parameters which are considered as a latent heat load sources and the sensible heat load sources. Some questions will be asked there definitely there in the examination. So I will stop this particular session for the time being, and in the next session we'll solve some numericals which are related to this design of an air conditioning system. Okay, I will take a break and take a full stop for this today's session, and hope that you are staying back home. Stay home, stay safe. That's all from my side. Have a good one.